That's how it is.
All right, we have your attention, please. Noah's going to explain to us how he did the bell ringer. Let's pay close attention so that way we know that we did it correctly. And Noah, whenever you read the words, will you please read them out loud? So that way those joining us on Google Meet can know what the coordinates are that you wrote down.
So it said do a 180 rotation. So that's negative A, negative B. I just put the signs on all of them. -2, -4, 2, 5, and 6, -7.
So he said -2, -4, +2, +5, and +6, -7. Logan, tell us, do you agree or disagree? Yeah, very good. Only thing I would add, I like how you put the rule on there, -A, -B. Only thing I would add is the parentheses around the quarter pairs. Okay. All right. What questions do you have for me on the bell ringer? Only if you're not going to be here tomorrow. Is there anyone that I think Emily told me she's not going to be here tomorrow? Oh, you're already at trade school. Yeah. Just put that you're not going to be here. Put absent on Friday, and you can go ahead and give it to me.
Yes.
All right, and then I need you to get out your 5.4 notes, dilations.
At first I hit a pole and then Noah destroys the clutch.
See, that's the first time I've gone up there too. That's the first time I did the bell ringer.
Why did you let go?
Why did I let go?
Because he was bolted.
Yeah, so I went down and let go.
You pulled it all the way down.
Yes, it did.
I wish I could take it off.
Yes, it did.
You know what? Dylan. Wait, how are you supposed to put him in? How are you supposed to put him in? Boy, I'm tired of that too. Take a cut.
All right, 5.4 dilations. Where have you heard the word dilations before?
When you get your eyes dilated.
Yeah, when you get your eyes dilated, they make your pupils bigger.
And I hate it when you walk outside.
Yeah, the reason for that is because usually when you go out in the daylight, your pupils get a lot smaller. That's so that way the sunlight doesn't damage your eyes. You don't get too much light in. And like right now in here, with it being dark, they'd be bigger. It's because they're trying to pull in more light so that way we can see. So whenever they dilate your eyes and make them bigger, that's taking in all that sunlight and it really hurts. That's why they're supposed to give you those special glasses to wear. Same thing that we're going to be doing. Dilations means making something bigger or making it smaller. Okay. And just how previously we had rules, we're going to have rules with dilations. All right. It always does that for some reason. A dilation either enlarges or reduces a figure to make a similar figure. So previously, the transformations made them keep the same size and the same shape. However, now, let's not lean on our hands so we're not going to go to sleep. Keep our hands off our face. All right, let's not rest on our, there we go. All right, so it makes them bigger or smaller. So now it has the same shape, it's just not the same size. So before it kept the same shape and size, but it no longer keeps the same size. It can either be bigger or smaller. So first you have a reduction. Okay, and notice you'll need to fill in the blank. A reduction is a dilation in which the scale factor K is between 0 and 1. The scale factor is how much bigger or how much smaller it is. Okay, so your scale factor, your reduction, is a dilation in which the scale factor is between 0 and 1. All right, so you need to fill that in on your notes. All right, we got that one written down, between 0 and 1. Okay, so what that means is it could be like 1/2, 2/3, 3/4, 7/8. You can also do it as a decimal, 0.25, 0.5, 0.75, or even as a percentage, 25%, 50%, 75%, 88%. Okay. An enlargement, hang on just a second, it skipped too far.
They're gonna see it. They're gonna see it.
Alright, an enlargement. It is a dilation in which the scale factor K is larger than 1. So an enlargement is whenever the scale factor, and we use the letter K, is larger than 1. Okay, look at this picture here. I had triangle PQR, and it was dilated to triangle P prime, Q prime, R prime. Well, you can look at that and see that it was an enlargement because the prime one is bigger than the original one. Okay, now what this C is, that's the center of dilation. That's like if you had a flashlight and you were shining it right here at C and you were shining it on this triangle figure. This new figure would be like its shadow that it cast.
Nice.
Okay. So that's the
So
dilation.
it's an enlargement.
Yes, that one's an enlargement because it's bigger.
Enlargement.
All right, the scale factor. How to find the scale factor? The scale factor of a dilation can be written as a fraction, decimal, or percent, and it's always the prime divided by the original. So it's CP prime divided by CP. So pretty much what that means is you take the size of the image and you divide it by the size of the pre-image. Okay? So that's how you find your scale factor. You take the size of your image, which is your new one, and you divide it by the size of the original one, the pre-image. Okay, so that's how you find your scale factor K. All right, so let me show you an example. It says, find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. So first you want to find from C to P prime, because that's the new one. Well, from C to P prime is 12, so that number goes on top. Then you want to do from C to P, which is the pre-image. So from C to P is 8. So my scale factor K is 12 over 8. Okay? And then you just reduce that. 12 divided by 8, I can divide those both by 4, and I get 3 over 2. Now, you can leave it as 3 over 2, or you can divide it, 3 divided by 2, and get 1.5. So my scale factor is 1.5. And it asks me, is it a reduction or an enlargement? Well, since this number is bigger than 1, that would be considered an enlargement. The only thing I see people making mistakes on here is getting confused about which one goes on top and bottom. The new image goes on top, the prime one, the old one goes on bottom. Okay. All right, let's try one together. Find the scale factor of the dilation, then tell whether it is a reduction or an enlargement. So first you're going to need to fill in these two numbers, which are 18 and 30. So fill in those two numbers, 18 and 30. Okay. All right, so then whenever you're trying to find your scale factor, C to P prime goes on top. Okay. Drake, what would be the distance from C to P prime? 18, awesome. So 18 goes on top. And then you do from C to P on the bottom. Carter, what's the distance from C to P?
C to P would be 30.
Awesome. So my K factor, or my scale factor, is 18 over 30, and I need to reduce that. Luke, what is 18 over 30 reduced to?
3 over 5.
3 over 5. Okay, so you can leave it as 3 over 5, or you can change it to a decimal. Logan, what's 3 over 5 as a decimal? 0.6. All right, Kaylee, would you say that that's an enlargement or a reduction?
It's a reduction.
Why is it a reduction?
Because it's less than 1.
Perfect. It's less than 1, so it's a reduction. Okay. What questions do you have for me so far?
9.
All right, let's try the next one. Again, you're going to have to fill in the number. Oh, yeah, you need to fill in the numbers. In a dilation from C to P prime is 3, and the length from C to P is 12. find the scale factor, then tell whether it's a reduction or an enlargement. All right, Alex, tell me, which number goes on top, the 3 or the 12? Why does the 3 go on top?
Because it's the simplified.
Perfect, so we got 3 over 12. Emily, what is 3 over 12 reduced to? 1/4. You can leave it as 1/4, or you can change it to a decimal. Harrison, what's 1/4 of a decimal?
0.25.
Okay, so 0.25, perfect. All right, Daniel, would that be an enlargement or a reduction? Perfect. All right, before you work with your partner, what questions do you have for me? Okay. All right, so I'm gonna have you turn and face your partner, work with your partner. You're gonna have to write down the numbers after you get with your partner before you can even work it out. So make sure if you turn and face your partner that you copy the numbers down. All right, go ahead, turn your desk, face your partner. Daniel, we're ready to work.
I'm not doing this side.
All right, your numbers on this one are 14 and 6. 14 and 6. So fill those in first. Then you need to find the scale factor and then tell whether it's an enlargement or a reduction. And we're do this one with your partner. All right, if I can have your, oops.
Times 2.
On this one here that you did with your partner, Tyler, what did you and your partner get for your scale factor?
We got 3/7.
3/7? Perfect. Now, if you would have changed this to a decimal, that, like I said, it's okay if you do it on an assignment, but if you're going to have to round the decimal, I wouldn't use it on big ideas. What would 3/7 be as a decimal? I think it was like 0.43. It was like 428. So the 8 makes a 2 run to a 3. But me personally, I would just leave it as 3/7. All right, so Luke, what did you and your partner say about this? Is it a reduction or an enlargement?
Reduction.
Does everybody agree with those answers?
Yeah.
Awesome. All right, here's your next one. First, you need to fill in the numbers. It's 9 and 15, and tell whether it's a reduction or an enlargement after you find the scale factor. All right, so work this one out with your partner. All right, if I can have your attention, please. Harrison, what did you and your partner get for the K for the scale factor?
So CP prime, I got 9. And for CP, I got 15.
And what did y'all get when y'all simplified that?
I simplified it and got 3/5, and I converted to a decimal and got 0.6.
Now, did y'all say that that was an enlargement or a reduction?
Reduction.
Is everybody okay with that? Is everybody okay with their answer?
I don't know, it's making me uncomfortable.
All right, go ahead and put your desks back where they go.
Liberals be like,
Liberal.
Alex, you
Alright, so let's move on to chunk 2. Now, just like with rotations, translations, and reflections, there were rules. For instance, with translations, xy was translated to x plus a, y plus b. With reflections, like a reflection over the x-axis, it was xy is translated to x comma negative y. Okay. All right. So with dilations, what the rule is, xy is dilated to k times x comma k times y. So for instance, if your scale factor was 2, then you could find your new coordinates by doing 2 times x and 2 times y. That's how you would find your new coordinates. You just multiply both the x and the y by the scale factor. All right, so let me show you an example. It says graph triangle ABC with vertices A2, 1, B4, 1, and C4, -1. and its image after a dilation with a scale factor of 2. Okay, so first let me draft the original. So A is 2, 1. B is 4, 1. And C is 4, negative 1. Also, whenever you're drawing your triangles, some people have not been connecting the points to actually make the triangle. Make sure you do that. Make sure you're actually drawing the triangle and not just plotting the points. All right, so now I need to get my new coordinates. Well, to get your new coordinates, your scale factor is 2, so you just go through each of these and multiply the coordinates by 2. So A prime, 2 times 2 is 4, and 1 times 2 is 2.
4, 2.
For B prime, 4 times 2 is 8, 1 times 2 is 2.
No.
And for C prime, 4 times 2 is 8, 2 times negative 1 is negative 2.
So the 1's always going to 2?
Only if the scale factor is 2. Because the scale factor tells you what to multiply by.
Okay.
Alright, and now you plot those points. 4, 2 would be to the right, 4 up 2. That's A prime.
It got excited and got bigger.
B prime is 8, 2. Now, does it make sense that it's going to get bigger?
Yeah, it does make sense.
Because our scale factor is bigger than 1. Now, what happened here? Our center of dilation is always going to be at the 0, 0. So pretty much like what's happening is we have a flashlight here at 0, 0, and it's shining on triangle ABC, and then A prime, B prime, C prime triangle is its shadow.
Okay.
It's bigger because
It got twice as large.
All right, what questions do you have for me? All right, let's try one together.
Why is it coming?
the smaller one is still okay, right?
This one you're going to need to fill in the scale factor. I left it blank on your paper, so make sure you fill that part in first. All right, so quadrilateral KLMN with vertices K negative 3, 6, L 0, 6, M 3, 3, and N negative 3, and its image after a dilation with a scale factor of 1/3. Okay, so first let's graph the original. Negative 3, 6 would be to the left 3, up 6.
These are a lot of points.
0, 6, 3, 3, and negative 3, negative 3.
What is it? Quadrilateral? Quadrilateral?
Yes.
Quadrilateral.
Alright, so there's my quadrilateral KLMN. Now I need to find my new coordinates, and my scale factor is 1/3. So you need to go through and multiply each coordinate by 1/3. So K prime is negative 3, 6. So what would be those coordinates if I multiplied it by 1/3?
Negative 1, 2.
Negative 1, 2. Awesome. What about L prime?
You multiply it by negative 1/3? I mean 1/3?
You multiply it by 1/3. What did you say, Kaylee?
0,
0, 2. Perfect.
Wait, what?
0 times 1/3 would be 0. 6 times 1/3 would be 2. Pretty much multiplying by 1/3 is the same as dividing by 3.
Well,
What about M prime? What would it be?
1, 1.
Awesome. And what about N prime?
Negative 1, negative 1, negative 1, negative 1.
Awesome.
negative one.
So K prime is negative 1, 2. L prime is 0, 2.
Roll with February, you got sad.
M prime is 1, 1. N prime is negative 1, negative 1.
Yeah, he shrunk up.
He got cold. That's okay. It's okay. Right?
Alright. What questions do you have for me? Yes.
I
Let's
think
go with
that's
Tyler.
except the L and M. Wait.
My man's
yes.
got cold.
Okay.
Man, that's cold.
Alright, let's try another one. Alright, yeah, still directed practice. You're gonna need to fill in these coordinates. P is -2, -1. Q is -1, 0.
Just a little.
And R is 0, -1. Okay, and the scale factor K is 4. So you're gonna have to write those in first,
Little like a shrimp.
and then draw your triangle. Okay. Alright, so in order to find my image, what am I gonna multiply all my coordinates by?
Trace. 4.
4. We're gonna multiply them by 4.
-8.
Alright, so what would P prime be?
I do not.
-8, -4, is that okay?
Yes, ma'am.
What about Q prime?
-4, 0.
And what about R prime?
0, -4. No.
You said 0, -4?
Mm-hmm.
Alright, so then we do -8, -4, -4, 0, 0, -4.
Wow, look at that.
Now, what questions do you have for me? Alright, on the next one, you're going to need to work with your partner, but before you do the problem, you're going to have to make sure that you write down the coordinates and the new scale factor. Alright, P is 5, -5, Q is 0, -5, R is 5, 5, and K equals -0.4. So this is the first negative one. Let's see what that negative does.
Let's get it on time.
Alright, once you have it written down, you need to turn your desk, face your partner, and work it out together.
We're working that time. I think we did good out.
Alright, if I can have your attention, please. So for your new coordinates for P prime, you should have gotten -2, +2. Q prime, you should have gotten 0, +2. And R prime is -2, -2. And then here are both of those graphed. What happened to the triangle PQR?
It flipped.
It flipped.
180 degrees.
Does it make sense that it's going to flip 180 degrees because you multiplied both the x and the y by a negative? Yeah, because we just did that 180 degree rotation, and it got smaller. It was a reduction. So that's really all you did to that triangle. You shrunk it by 0.4 with a scale factor of 0.4, and then you rotated it 180 degrees. That's what the negative does. All right, here's your next one. Try this one. X is 2 you're going to have to fill in the coordinates first. X is 2, -1, Y is -2, -2, Z is 1, 2, and your scale factor is 3. Alright, if I could have your attention, please. For X prime, should have gotten 6, -3. For Y prime, -6, -6. And for Z prime, 3, 6. And this was your original, your pre-image. And then in the yellowish orange is my image. Let's pretend like it's straight. Alright, what questions do you have for me? Alright, this will be page 25 of your notes. Stay with your partner. Stay with your partner. Stay with your partner. This is page 25. It's 5.4 dilation. But do not put your notes away. You're going to live down.
Can I tear it out?
Out of your student journal?
Yes.
Yes.
Okay. What page?
The notes is page 25.
95.
25 of your notes.
95 student journal?
No. In your student journal, I need you to turn to page 120, and I've made some changes.
Oh. Because you gave the right look.
What page?
120. Alright, for your student journal, you should be on page 120. Someone else has already used that. You can do it on graph paper. You can look up there and do it on graph paper. Alright, so turn to page 120. For number 1, I need you to change the ordered pairs. I need you to change the ordered pairs for number 1. For A, it should be -2, 3. For B, it should be -3, 2. C should be -1, 0. And D should be 0, 2. Now, on here, you see how it tells you to do a translation and do a dilation? Don't do the translation. Only do the dilation. So you can mark out translation. So mark out translation.
On all of them?
That's the only one that has it.
Then look at number 2. See how it says dilation, then a reflection? Mark out reflection. Only do the dilation. And same thing on number 3. Mark out the rotation and only do the dilation. Okay, notice, like on number 3, 2/3 times x. That's your scale factor, 2/3. So it means multiply them both by 2/3. All right, so you got numbers 1, 2, and 3 to complete. You'll have the rest of the class, which is about 10 minutes. Whatever you don't finish will be homework due at the beginning of class tomorrow. Was there anyone that did not get those coordinates written down for part A? I will put them back up here. So there's the new coordinates for A. Those are the coordinates you should use for number 1.